This is the 4.8 to 4.10 review. Calculators still are not allowed. And in this one, we're given the velocity of a particle moving along the y-axis is given to us. The particle moves upward until it reaches the origin, and then it moves downward. The position of the particle at any time is given by something. Okay, so the first thing we're going to do is we're going to use the fact that velocity is the derivative of the position. So we know the velocity is 24 minus 3t, so that means the position will be the antiderivative of this. So that will be a 24t minus a 3t squared over 2 plus some constant. Now in order to find the constant, we're going to have to use the information about a point on one or both of the curves. So here it says we move upward until it reaches the origin and then it moves downward. So when we're moving and the direction that we're moving, that's given to us in the velocity curve. So that means we're going to move upward and then move downward. That means we're going to change direction. That means my velocity is going to be 0 when I reach the origin. So if I set that velocity equal to 0, then I can solve for the time and get time equals 8. What that means is that I now know that on the position curve, when I have a time of 8, I'm going to be at the origin. So that means I've got the point 8, 0 on the position curve. So I can now use this point 8, 0 to nail down the c. That means I know my position is 0 when my time is 8. So my c will be, let's see, what is that? An 8 squared is a 64 divided by 2 is a 32 times 3 is a 96 over a 24 times 8. I end up with a c equals a negative 96. So my position curve will now be a 24t minus a 3/2 t squared minus a 96. Okay, so let's look at part B, which appears to work the exact same way. We've got the velocity, we've got it moves left until it reaches the origin and then it moves right, so that means we're changing direction, or the velocity will be 0, and the position is going to be given by the antiderivative of this, nailed down by the given point. So first we can write down the velocity, which is t squared minus 16, and we can write down the position function, which will be the antiderivative of this. Add 1 to the power, divide by 3, minus 16t plus some constant. Now we know the velocity is going to be 0 when we reach the origin. So that means we have a t minus 4 and a t plus 4 is going to equal 0. So that happens when t is 4 or negative 4. But I was given that t must be positive, so that means I'm not going to use the negative 4. I'm just going to use the positive 4. And I have been told that at this time I'm going to be at the origin. So that means the position when time is 4 is going to be 0, or we'll have the point 4, 0 on the position curve. So I plug that in here. I end up with a 0 when I plug in 4. Solve for c, I end up with 128 over 3. So that means my position curve will now be nailed down to a t cubed over 3 minus a 16t plus a 128 over 3. Last part, part C. Same scenario. We're moving left, and then we reach this point, and then we move right. So instead of being at the origin, we're going to be changing position at the point 2, 2. So we're moving along this line, y equals 2, and our velocity is given. So v of t is a 2t minus 6. That means that that velocity will be 0 when t equals 3. So that means my position when time is 3 is going to be the x-coordinate of 2. So that means my antiderivative, or my position function, will be a 2t squared over 2 minus a 6t plus a constant. If I simplify that, I get a t squared minus a 6t plus that constant. And now we're going to use the point 3, 2 on the position curve to nail down the c. So that means I know that the position is 2 when I plug in a 3. Solving for c, I'll get c equals 11. And then I can write down my position curve by plugging in the c that I have just found. And we're done.